The year is 1946. The war is finally over, but the world is still shaking from everything it just survived. Nations are exhausted, industries are broken, and technology is sitting in a strange space between old world engineering and the new atomic age. Among the ruins of Europe, America is gathering documents, scientists, and machines like a farmer gathering scattered grain before winter. Everyone knows the future is rockets. No one knows how to build them. Hidden behind military fences in Southern California, a small team is given a mission that barely anyone remembers today. The United States Air Force assigns a contract to the Consolidated Vultee Aircraft Corporation, Convair. Their assignment carries a cold, bureaucratic name, Project MX-774. On paper, it is nothing more than a high-angle ballistic test vehicle. In reality, it becomes the first American rocket project to explore the design foundations of modern spaceflight. At the same time, most of the world's attention is locked onto German technology. The V-2 rocket is everywhere. Photographed, analyzed, disassembled, shipped, and tested. The German scientists under Operation Paperclip receive headlines. Meanwhile, the engineers at Convair work quietly in the shadow, trying to design a rocket that does not copy the V-2, but replaces it with something more stable and more efficient. MX-774 is born with a disadvantage from the start. It has a budget that is so small, the engineers joke it could barely buy a decent aircraft engine. The United States is demobilizing, cutting spending, cutting research, and pushing almost every project toward cancellation. Under these conditions, Convair decides to do something bold. They will experiment. They will use this small opportunity to test every idea the Germans never used, every idea that was too advanced for wartime pressure. The first major decision is radical. Instead of building the rocket with a thick metal shell like the V-2, Convair designs a thin-skinned, pressure-stabilized tank. The idea is simple but revolutionary. The rocket will stand upright only when its fuel tanks are pressurized. Without pressure, the metal skin collapses like a crushed soda can. No other country has attempted this. Engineers understand the risk. A single leak, a single valve failure, and the entire vehicle folds instantly. But if the design works, the rocket becomes far lighter and far more efficient. The second innovation is even more ahead of its time. Convair introduces gimbal steering, a method where the entire engine moves to control direction. The V-2 relied on aerodynamic fins and separate steering vanes inside the engine exhaust. MX-774 abandons all that. The team wants the rocket to steer the way modern space vehicles steer, by swinging the engine itself. This is the first American program to attempt full engine gimbaling. These ideas, years later, will become the heart of the Atlas rocket, the Titan rockets, and even modern launch vehicles like Falcon 9. But in 1946, they are nothing more than risky experiments. The government begins evaluating the cost. The team begins building the rocket piece by piece. Test tanks buckle, valves jam, fuel systems leak. Engineers weld through the night in hot workshops filled with metal dust and the smell of new alloys. The world sees none of this because the project is too small and too early to receive attention. But slowly, a new kind of rocket emerges from the research hangar. Convair names it HIROC, short for High Altitude Rocket. Its purpose is simple: reach upper atmosphere altitudes and collect data. But internally, the engineers hope it can become something far more powerful, a precursor to America's own space-class launch vehicle. By late 1947, the design is ready for flight tests at White Sands, New Mexico. The desert air is cold. Technicians roll the rocket out like a long metal cylinder that looks almost fragile, its thin skin not yet inflated by pressure. Once fueled and pressurized, it becomes something else, a sleek, tall structure that looks years ahead of its relatives. The countdown begins for the first test. The engine roars. For a moment, the rocket rises. Then it tilts, loses control, and crashes. The first flight is a failure, but the data is incredibly valuable. Engineers study every second of the launch and learn that their gimbal system needs tighter control. They upgrade the design and prepare for a second attempt. The second test fires perfectly. The rocket lifts smoothly, climbs high into the desert sky, and executes the steering movements exactly the way the engineers hoped. Even though the mission ends in a breakup at high altitude, The U.S. Air Force is impressed. The concept works. The ideas work. MX-774 has potential. But politics does not care. In early 1948, the Air Force cuts the program entirely. The budget disappears. Personnel are reassigned. Rocket parts are sent to scrap. Files are closed, boxed, and forgotten in storage rooms. In total, MX-774 launches only 3 test vehicles. For most people in the military, this tiny experimental rocket is nothing more than a footnote. With no operational purpose and no military urgency, the project becomes a ghost. But the engineering team at Convair does not forget. They keep copies of the designs, calculations, and data. When the Cold War escalates, the government suddenly demands a new intercontinental ballistic missile. Convair proposes a design that uses the same pressure-stabilized tanks, the same gimbal steering, and even the same overall structure. That missile becomes the Atlas, America's first operational ICBM, launched in 1957. Atlas later evolves into a space launcher that carries astronauts like John Glenn and Gordon Cooper into orbit. Every successful Atlas rocket carries the DNA of MX-774 inside it. Yet MX-774 itself receives almost no recognition. Its photographs remain buried in dusty archives. Its story rarely appears in textbooks. Even its surviving hardware is almost non-existent. The early rockets were destroyed during tests, and the remaining materials were quietly scrapped when the program was defunded. The forgotten nature of MX-774 is almost surreal. This was the first American rocket to use technology still present in modern vehicles. But because the world was still recovering from war, and because German technology overshadowed everything, the MX-774 became invisible. The story becomes more interesting when looking at how close America came to losing this technology completely. If Convair had not preserved their notes, the United States would have had to reverse engineer these concepts again in the mid-1950s, wasting precious years during the early Cold War. Instead, a few dedicated engineers kept the designs alive, protected them, and built the foundation of an entire launch family. The collapse under pressure fuel tank is perhaps the most fascinating part. When the Atlas was finally revealed to the public, journalists were shocked to discover that the missile could not even stand upright when empty. Photographers watched the empty tanks bend and wrinkle like a sheet of aluminum. This strange design, first created for MX-774, turned out to be shockingly efficient. It remains one of the lightest structural solutions in aerospace history. The influence of MX-774 continues quietly through later decades. Even though its name is nearly erased from popular culture, aerospace historians consider it one of the most important early American rocket programs. It marks the moment the United States stopped copying German designs and began creating its own path toward space. Looking back at the 1940s, MX-774 represents pure ambition. The world was still healing. Technology was uncertain. Nations were exhausted. Money was tight. Yet a small team of engineers in a dusty workshop built something far ahead of its time. Something bold. Something too advanced to be appreciated in its own era. Today, very few people know the name MX-774. Fewer know what it achieved. But its shadow appears in every launch vehicle that followed. Every pressure-stabilized tank, every gimbaled engine, every stage that balances weight and strength with precision, it all traces back to this forgotten rocket. Forgotten programs are often quiet. They do not explode into headlines. They do not survive budget cuts. They do not leave monuments behind. But they leave ideas, and sometimes ideas are enough to change history long after the program itself disappears. MX-774 lived for only 2 years, but the ideas it tested carried the United States from the end of World War II into the dawn of human spaceflight. A small project that ended early, yet still reached farther than anyone realized. A rocket that never made it to space, but helped build the rockets that finally did.